Hi, I'm Adolph Oliver, and this is a video clip dealing with word problems that are about proportions. Now, proportion is simply two fractions equal each other. Here's an example here. I've got units in here. We'll talk about those in a moment. But 2 over 4 equals unknown over 10. Well, there, of course, are two numerators and two denominators here, a total of four things. If you know any three of those four, like the numerator here, denominator here, and denominator there, you can solve for the missing one. A common solution method is to use the means and extremes, which is just a shortcut to convert these guys to a common denominator, saves a lot of time. Here's what you do. Looks like I'm crossing this out, drawing a big X right through the middle of it here. But these are guidelines. One of them is the means line, the other is the extremes. And one of the things about problems where you have a single fraction in each side is that if you multiply together the things in one arm, they equal the things multiplied together on the other arm. So here we go. We can simply multiply together these guys. Notice it's the x that we want to have, so we're solving for. So let's take this arm first. You can take either one. And I get 4 times x equals 2 times 10. Well, of course, now that can easily be solved for x. But let's talk a little bit about what's going on here again, because we're going to look at some examples. Proportions are easy to do once you've seen the method. Now, that problem we just talked about came from this word problem itself here. 2 bags of strawberries cost $4. How many can be bought with $10? Okay, let's pretend that we're just starting fresh with this word problem right here. And the thing that we know is that 2 bags cost $4. Those are two things that are related to each other. So that allows me to set up my first fraction. Doesn't make any difference who you put on top and who you put on the bottom on the first fraction. But after that, it does make a difference in what you do on the second one. So here's the idea. Again, 2 bags cost $4. There we go. Equals. Now, here comes the second fraction. We're going to have one of the numerators or denominators will be given, and the other one we'll be solving for. But since I decided to put bags up on top on the first guy, I've got to have bags on top on the second guy. And since I had dollars in the bottom, dollars on the bottom have to be here. In other words, the types of units have to match across the top and across the bottom. You can set your first guy up either way you want here, but once you do that, then you've got to be consistent. Well, how many can be bought with $10? Okay, we know that $10. How many can be bought is our X. So that is how you'd set it up. Real simple to do. Once again, we're going to do the means and extremes business. Remember that this only works when we have a single fraction, top and bottom. I'm going to take the arm with the x on it first, simply to get the x on the left. 2 times 10, so I've got 4x, okay, equals 20. Divide both sides by 4. Looks like x equals what, 5 bags? Okay, so that's how many we can buy. Okay, well, again, like I said, proportions are pretty easy things to work with. Let's now look at some examples of these proportions. So here we go. One of the things is they can be used for monetary conversion. We're looking at some simple examples here to see this. The money used in Kuwait is called the dinar. The exchange rate is $10 equals 3 dinars. Find out how many dollars you would receive if you exchange 15 dinars. Okay, well, the first fraction has to be set up with two things that are both known and relate to each other. And so the thing that we got that relates here is the $10 and the 3 dinars. Okay, so let's set up $10 over 3. I'll just use D for dinars. Now, there's my first fraction. I could have put dinars on top and dollars on the bottom. You'll get the same equation and answer either way. But once you set this first one up, you got to be very careful to set up the second one with the same units. So dollars on top, dinars on the bottom. Now find out how many dollars you would receive if you exchange 15 dinars. Okay, so I have 15 dinars and I don't know how many dollars. So there's our equation right there. Okay, well now, let's do the means and extremes. Okay, we're solving for x, so I'll take this arm first. You can take either arm. 3 times x equals 10 times 15. Now remember, this little means and extremes trick like this only works when you have a single fraction on both sides. And what it really does is it clears out and gets you to a common denominator. It just does it a lot quicker. Okay, well now, let's see what we've got here. I've got 3x equals 10 times 15. That looks like 150. Divide both sides by 3. Looks like x equals 50. Okay, so that would be how many dollars, x is in dollars again, that you would get. Okay, well, there's another little one we got right down here on the same page. Let's take a look at it. And it says, if you can buy 1 bag of potatoes for $1.50, then how many can you buy with $19.50? Well, okay, we got to set up the first fraction. We're getting 1 bag for $1.50. Well, let me just put the $1.50 on top. Here it is, and 1 bag on the bottom. You could have set it up, the bag on the top and the dollar on the bottom. Again, your choice in the first fraction. But after you decide that, you have to have the same units going across. So it'll be dollars up above and bags on the bottom. Okay, well now, how many can you buy with $19.50? Well, we got the dollars, so here it is. What we don't know is the number of bags. So here that happens to be. Okay, well again, means and extremes here. Looks like you're crossing out the problem, but we're not. What we're simply doing is reminding ourselves how we can multiply together to get the equation. Now, always look for the arm that's got the variable on it, this one here. So I'm going to take 1.50 times x. Okay, here it is, 1.50 times x, and set it equal to the other arm, 1 times 1950. Okay, well, here we go. We just home in now on the example or the answer on this. 1.50 times x equals 19.50. Okay, divide both sides by 1.50. Okay, and let's see, it looks to me like we get x equal to, well, what's it going to be? If we go 7, 8, 9, how about 9? Well, let's just say 1950 divided by 1.5. Okay, if you're having a little trouble with that like I am at the moment, 19.5 divided by 1.5, okay, equals, well, let's try this again, 19.5 divided by 1.5, okay, 13, 13 bags. Okay, so there it is. We had to divide both sides by 1.5. 19.5 divided by 1.5 gives us x equals 13. So what can we get here? We can get 13 bags. Okay, let's look at a couple more examples here. Like I said, doing these proportions is a fairly easy thing to go. Here's another example coming up right here. Okay, let's read through this one. John reduced the size of a frame to a height of 1 inch. What is the new width if it was originally 8 inches wide and 2 inches tall? Okay, well, these are the two things we know about the frame and one of its conditions here, what it originally was. So I can say it's 8 inches wide divided by 2 inches tall. Okay, now remember, here's what you do. You simply take two things you know that have to do with the same thing, the original frame, 8 inches wide, 2 inches tall. Make a beginning fraction out of this. You could put either guy on top, either guy on the bottom, but once you decide in that first fraction, then you got to make sure that you put the wide guy on top here and the tall guy on the bottom on the second fraction. Okay, well, he wanted to reduce the size to 1 inch. Okay, and that's the height, I should say. He wanted to reduce the height to 1 inch. That's how tall you are. So here we go. 1 inch tall, and x inches here is going to be the width. That's what we want to find. Okay, once again, the means and extremes. Take the arm again that has a variable on it, just so we get it on the left. Might as well do that and make it easier on ourselves. So 2 times x equals 8 times 1. Okay, well, this is 2x equals 8. Got to divide both sides by 2. Looks like x equals what? 4. Then that we get 4 inches, and this will be how wide it is once you've reduced it. Okay, well, one last example to look at here. Like I said, once you see how these guys go, they're pretty darn easy to set up. If you can buy one bag of carrots for $3.40, how many can you buy with 17 bucks? Okay, well, the one thing we know is that one bag equals $3.40. So let's just set up our first fraction that way. Okay, and again, you can put whoever you want on top. So I usually take the first guy and just put him on top and the second guy on the bottom. But then be very careful how you set up the second fraction. This is what's critical here. We have to have the number of bags upstairs and the dollars downstairs. Okay, well, it says we got $17 and we don't know how many bags, so that's what we want to find out. So here it is. Now, once again, let's do our means and extremes here to be able to quickly come up with the equation to solve this. And remember, it looks like you're crossing out the problem, but you're not. These are just the guidelines as to what to multiply together. Take the arm that's got your variable on it first, so you get that on the left side. So we got 340 times x equals 1 times 17. Okay, well, here we go. That's not difficult to work with. 3.40x equals just going to be 17. Can put 2 zeros behind it if I want. I got to divide both sides by 3.40. Okay, so what's this going to turn out to be? Well, we reduced the 3.40s there. So I've got 17 here, and I'm dividing it by 3.4. So if you get your calculator out and do that, looks like x equals 5. So we can get ourselves 5 bags of these potatoes, or carrots, I should say, 5 bags of carrots for the $17. Okay, well, proportions are simple things to do, and we've worked some examples here. So keep in mind the means and extremes trick to be able to solve these.